Solving systems of linear equations by elimination. So example 1, solving a system of linear equations by elimination is what we're going to be doing for letter A. So we have two equations, x plus 3y equals -2 and x minus 3y equals 16. So we have multiple steps that we're going to follow. Step number 1, we are going to multiply, if necessary, one or both equations by a constant. So at least one pair of like terms has the same or opposite coefficients. Now I'm going to rewrite my two equations just because they're not matching up exactly how I would like them to. So I have x plus 3y equals -2, and then I have x minus 3y equals 16. So what step number 1 is essentially asking, I'm going to highlight right here, asking you to do, is to find is to make sure that your x's or your y's are the same, or at least have the opposite coefficient. So you'll notice that I highlighted a positive 3y and a negative 3y. So those are actually opposites of each other, but our y's are the same. They both have 3. So step number 2, we are going to add or subtract the equations to eliminate one of the variables. So if we take x plus 3y equals -2 and x minus 3y equals 16, we're going to add the equations. So that becomes, and if you want, you can put an imaginary 1 in front of both your x's. 1x plus 1x equals 2x. Positive 3y minus 3y, well, that becomes plus 0, equals -2 plus 16 is 14. The left side simplifies to 2x equals 14. Divide both sides by 2. You get that x equals 7. Step number 3. Solve the resulting equation for the remaining variable. So I'm going to take one of the two equations. I'll do the first equation, x plus 3y equals -2, and I'm going to substitute x equals 7 in. So 7 plus 3y equals -2. Okay, can't combine anything on the left side, so I'm going to extend my equal sign and subtract 7 from both sides. 3y equals -9. I'm going to bring this up to the right. It's the random space. 3y equals -9. Dividing both sides by 3, I get y equals -3. So then step number 4 is to substitute p-value from step 3 into one of the original equations and solve. So we actually did that in step number 3. So the information from step 3 should be brought down into step number 4. All right, so let's try this. So we're going to solve the system of linear equations by elimination. So for the first equation, 2x minus y equals 9, and 4x plus y equals 21. All right, so let's look at our x's and look at our y's. If you notice, our y's are both having the same coefficient of 1. If you don't see that, you can put imaginary ones in front of both of them because there's technically one y. All right, so because of that, we want to go ahead and we don't have to multiply by anything different. So let's go in and add our equations. And the reason we're adding them is because there's a negative 1y and there's a positive 1y. So 2x plus 4x becomes 6x. Negative 1y plus 1y is 0. 9 plus 21 becomes 30. 6x equals 30. Divide both sides by 6. You get x equals 5. So the x value of our ordered pair is 5. Now we're going to go on to step number 4. And we're going to replace 5 inside of one of the two equations. It doesn't matter which one. I'm going to choose the first one. But again, it doesn't matter. So 2x minus 1y equals 9. So this becomes 2 times 5 minus 1y equals 9. 10 minus 1y equals 9. Extend my equal sign, subtract 10 from both sides. Negative 1y equals negative 1. Divide both sides by negative 1. You get y equals 1. So your ordered pair is 5, negative 1. That's your solution. All right, let's try letter C. 3x plus 4y equals negative 6. 7x plus 4y equals negative 14. Well, our x's are not the same, but once again, the y's happen to be the same. In fact, this time, not only are those the same, but their signs are the same. So they're both addition. That means that we need to subtract. So what I'm actually going to do is I'm going to multiply the entire second equation by negative 1. That gives me negative 7x minus 4y equals a positive 14. The first equation I'm going to keep exactly the same. 3x plus 4y equals negative 6. Because my y's are now opposite of each other, I'm going to add my two equations. 3x plus negative 7x is negative 4x. Plus 4y minus 4y is 0. Equals negative 6 plus 14 is going to give me 8. So negative 4x equals 8. I'm going to divide negative 4 from both sides, and I get x equals negative 2. I'm going to plug my x equals negative 2 into, again, doesn't matter which equation. I'm going to use the first one. So 3 times negative 2 plus 4y equals negative 6. So negative 6 plus 4y equals negative 6. I'll extend my equal sign and add 6 to both sides. 4y equals 0. Divide both sides by 0. Divide both sides by 4. And we get y equals 0. So that means that my ordered pair is at negative 2, 0. Example 2. Solving systems of linear equations by elimination. So we're going to solve the system by elimination. Negative 2x plus 5y equals 25. And negative 2x minus 4y equals 14. Well, neither x nor y values are exactly the same. The coefficients aren't all matching up. So it's up to you on whether or not you want to get the y's to be the same or the x's. I personally am going to choose the x's because negative 6x and negative 2x has less work than changing 5 and 4. So I'm going to actually change that second equation to be a positive 6x. And in order to do that, I must multiply the second equation by negative 3. Now the reason why I want to change the second equation to a positive 6 is because I already have a negative 6 in the numerator. So if I have a positive 6 in the denominator, I can add the equations. So negative 3 times negative 2x becomes positive 6x. Plus negative 3 times negative 4y is a positive 12y. Negative 3 times 14, bear with me a moment, negative 3 times 14 is a negative 42. So then I'm going to add both my equations. Negative 6x plus 6x is 0, plus 5 plus 12y is 17y, and then 25 plus negative 42 is a negative 17. Left side becomes 17y equals negative 17. Divide both sides by 17, you get y equals negative 1. So that is the solution for the y. Now we need to plug it back into one of the equations to get the answer for the x. I'm going to plug it into the second equation. Again, it doesn't matter. It's whichever one you prefer. So then, negative 2x minus 4 times negative 1 equals 14. There's subtraction, so I'm going to add and make that a negative 4. Negative 2x plus 4 equals 14. Extending my equal sign and subtracting 4 from both sides. Negative 2x equals 10. Divide both sides by negative 2. You get x equals negative 5. So negative 5, negative 1 is going to be the solution. So let's try this on your own. We're going to solve the system linear equations by elimination and check on the solution. All right, 3x plus y equals 11. 6x plus 3y equals 24. Well, we have to multiply to get the same coefficient. You can either multiply and make the x's the same or the y's. I'm going to choose the x's because I just have to multiply by a negative 2. The y's I could have multiplied by negative 3. That would have worked. So negative 6x plus negative 2y equals negative 22. And then the second equation, I just rewrite it. 6x plus 3y equals 24. I'm going to add these equations. 0 plus 1y equals 2. Y equals 2. Okay. Y equals 2. I'm going to plug it into one of the original equations. 3x plus y equals 11. 3x, and I'm sorry, y equals 2. So 3x plus 2 equals 11. I'm going to subtract 2 from both sides. 3x equals 9. Divide both sides by 3, and you get x equals 3. So the ordered pair should be 3, 2. Now just to confirm this, I'm going to plug it into the second equation. I'm going to do my little check right here. 6x plus 3y equals 24, and I'm using the point 3, 2. So 6 times 3 plus 3 times 2 equals 24. 18 plus 6 equals 24. 24 equals 24. Check, that is correct. All right. Letter F. 5y equals 15 minus 5x, and y equals negative 2x plus 3. Okay, well, these equations are not written where they're matching up with the x's and the y's, so I'm going to change that. In my first equation, I'm going to add 5x to both sides, and that's going to become 5y plus 5x equals 15. Second equation, I'm going to add 2x to both sides, so that becomes y plus 2x equals 3. Now, if you notice, the x's and the y's don't match up, meaning that you don't have the same coefficient. I'm going to add in a 1 in front of that first in front of the y in the second equation. Okay, You can either make the x's the same or you make the y's. I personally am going to make the y's because between 5 and 1, the smallest number that they both go into is a 5. So I'm going to multiply the second equation by negative 5. So the first equation still stays 5y plus 5x equals 15. Second equation becomes negative 5y minus 10x equals negative 15. So we have 0 plus negative 5x equals 0. Negative 5x equals 0. Divide both sides by negative 5. You get x equals 0. All right, so I'm going to take the original equation, y equals negative 2x plus 3. I'm going to put x equals 0 in. So y equals negative 2 times 0 plus 3. You get y equals 3. So the ordered pair 0, 3 should be the correct answer. So I'm going to check my work. Okay. 5y equals 15 minus 5x. Taking the ordered pair of 0, 3. So 5 times 3 equals 15 minus 5 times 0. So 15 equals 15 minus 0. 15 equals 15. Check yes. Example 3, real life application. You buy 8 hostas and 15 daylilies for $193. Your friend buys 3 hostas and 12 daylilies for $117. Write and solve a system linear equation to find the cost of each daylily. So let's make your equation first. You buy 8 hostas and 15 daylilies for $193. So let me just go back in here and write that x equals hostas and y equals daylilies. Okay, your friend, let's make their equation, buys 3 hostas and 12 daylilies for $117. So we wrote our system of linear equations. Now we're going to go in and figure out the cost of each daylily. So we either need to make the x's the same or the y's. So the x's, 8 and 3. The y's, 15 and 12. So I'm going to get the x's the same because those are smaller numbers. So 8 and 3 can both fit into 24. To get 8 to become 24, you have to multiply it by 3. So the first equation becomes 24x plus 45y equals 193 times 3, 579. The second equation, to get from 3x to 24, I had to multiply by 8. But I'm actually going to multiply by negative 8, so that way I have my opposite sign. So negative 24x plus 12 times negative 8 is negative 96y equals 117 times negative 8 is negative 936. All right, so I'm going to add these. 24x plus negative 24x is 0, plus 45y minus 96y is negative 51y, and 579 minus 936 is negative 357. So the left side simplifies simplifies negative 51y equals negative 357. So I'm going to divide both sides by 51. y equals 7. So that means, I'm sorry, then we're going to take one of the original equations and we're going to solve for the x. We know that y equals 7. Doesn't matter which one, I'm going to take 3x plus 12y equals 117. So I'm taking the original second equation. I know that y equals 7. So I'm going to plug that into my equation. 3x plus 12 times 7 equals 117. 12 times 7 is 84. So that becomes 3x plus 84 equals 117. I'm going to subtract 84 from both sides, which gives me 33. Dividing both sides by 3, we get x equals 11. So we have the answer of 11 comma 7. But again, we want to explain what that means. So, hostas cost $11 each, and daylilies cost $7 each. Let's try this next one. A landscaper buys 4 peonies and 9 geraniums for $190. Another landscaper buys 5 peonies and 6 geraniums for $185. Write and solve the system's linear equations to find the cost of each peony. Well, the first landscaper buys 4 peonies, 9 geraniums for $190, while another landscaper buys 5 peonies and 6 geraniums for $185. So that's how we're going to set up our two equations. 4x plus 9y equals 190. Second equation is going to be 5x plus 6y equals 185. Over to the side, I'm going to specify that x is the number of peonies and y is the number of geraniums. Okay, so we're going to look at our x values. We have 4 and 5. The smallest number that they both can fit into is 20. Then we have 9 and 16. The smallest number they both fit into is 18. So I'm actually going to go in and I'm going to change my y values. If you prefer to change your x's, that's fine. So for the first equation, I'm going to multiply that by 2. That becomes 8x plus 18y equals 190 times 2 should be 380. Then for the second equation, I'm going to multiply it by a negative 3, and this is just so then that way I can get a negative 18. So the second equation becomes negative 15x minus 18y equals, well, 185 times negative 3 is negative 555. So I'm going to add these two equations. 8 plus negative 15x is negative 7x. 18y plus negative 18y is a 0. And 380 plus negative 555 is negative 175. So this becomes negative 7x equals negative 175. And divide both sides by negative 7. Get x equals 25. Okay. So we have our x value. Now we want to solve for our y value. Doesn't matter which equation you choose. I'm going to choose the first equation. Right, so 4 times 25, oops, I actually wrote 24, plus 9y equals 190. So that's 100 equals 9y. 100 plus 9y equals 190. Dividing both sides by 100, you get 9y equals 90. Dividing both sides by 9, get y equals 10. So I have the ordered pair of 25, comma 10. So this means that it is $25 per peony and $10 per geranium.